Okay, good morning. This video is only going to go over the homework. I'm going to post two other sheets that are kind of like review things. And then I will give you the answers to some Regents questions that are there. I will also post your test this morning, and that will be due tomorrow at 3:15. So no homework except studying for tonight. All right, so this was your homework. Let's take a look. For the electrochemical cell below, this is not electrolytic. The reason I know it's not electrolytic is that there are two containers and there's no battery here. Electrochemical, you will have two containers. There's also a salt bridge. Okay. So the first thing we're going to do is label the anode and the cathode. And the way I do that is I'm going to look into my CRT and look on table J. Remember that those metals that are above the others are more active, and what that means is they're going to get oxidized. Those below another metal will get reduced. So let's see what metals we're dealing with here. We've got aluminum and cobalt. So aluminum is here, cobalt is here. That means aluminum is going to be oxidized, cobalt is going to get reduced. Okay, so what's our mnemonic for this? Well, you should remember an ox and red cat. Okay, so anox means oxidation happens at the anode. So we just looked on table J and saw that aluminum is going to be oxidized. So that means this is the anode. So this is going to get oxidized. Remember, another mnemonic that I gave you, I think, is van. That means in a voltaic cell, like this one, voltaic or galvanic, the anode is negative. So this is negatively charged, in case they ask that too. Okay, cobalt, red cat, cathode reduced. So we just saw that cobalt would get reduced, and that means this is the cathode. Okay, good so far? Okay, hopefully that's focused. It's hard for this to see. Okay, we labeled that. Check. Write the half reactions and the balanced net reaction. All right, let's look here. Now we've got solutions in here, right? So this is a metal strip of aluminum. This is a metal strip of cobalt. These are solutions. Now it doesn't tell you what the negative part of the solution is, so it doesn't really matter. So let's look at the half reactions. Aluminum and aluminum 3+. Well, we said aluminum is going to get oxidized. So when aluminum gets oxidized, we start out with Al, 0. You could even put a little solid there. And by the way, on homeworks, I'm seeing that people are leaving that out. Always put a charge, whether it's 0 or positive or negative, always put the oxidation number on top. Okay, so this is going to lose electrons to form aluminum plus 3. How many electrons did it lose? Well, I've got positive 3 over here. I've got 0 here. That means it must have lost 3 electrons. Positive 3, negative 3, 0. How about cobalt? Cobalt is going to get reduced here. So when it gets reduced, remember Leo-Ger? Leo-Ger, loss of electrons, oxidation, gain of electrons, reduction. So it's going to gain electrons. And it's going to form cobalt, solid metal. So how many electrons do I need in order to counter that positive 2? 2. So I've got the half reactions, but I don't have the balanced net reaction yet. That's going to take another step. So we did half of that. Let's look at letter C. We're going to label with arrows in the appropriate place the direction of electron travel. Okay, so let's look at our half reactions again. We've got aluminum that's losing electrons. So this happens spontaneously. The aluminum is going to lose the electrons in its sea of mobile electrons, and those electrons are going to flow through the device or the voltmeter. Remember, voltmeter measures how much electron flow is going in. And the device means it could very well just be a light bulb. Okay, you could hook a light bulb or something else in there. So the electrons flow through. They're going to continue down and then meet with the cobalt strip. When the electrons get here, you can see that those electrons coming from the aluminum end up getting added by the cobalt 2+ in the solution and then forming cobalt solid. So what's happening here is the electrons from the aluminum are going to flow to the cobalt, and then it's going to cause the cobalt to gain mass. In other words, what I'm drawing here is extra cobalt that has gotten converted from cobalt 2+ into cobalt solid. Okay? Now over here, the opposite's going to happen. I start with an aluminum strip here. The aluminum is going to lose electrons, and when it loses electrons, what happens? It starts to form aluminum ions. So when that happens, it's going to start to deteriorate. So this is going to lose mass, and you would see that in the strip. Okay, it's going to start to break down. Okay, so there's my electron travel. Always goes from anode to cathode. Electrons always flow from anode to cathode, and the way to remember that is it goes from alphabetically from A to C. Okay? Now what about the positive ion travel? Let's remind ourselves of what this thing here is. Remember, this is a salt bridge. The salt bridge is there to make sure that the charge on both sides is about the same. Because if I build up too much charge on one compared to the other, it's going to impede the electron flow. Okay? So, you know that electrons are flowing away from this. And when that happens, aluminum is starting to increase. So the amount of aluminum here is increasing. So if I increase these positive ions, that means it's becoming more positive, which is the same thing as becoming less negative. So what's happening over here? I've got cobalt here that's gaining electrons. So when these cobalt ions are here, they're getting converted into cobalt solid. So these are disappearing. So in this case, these are getting less positive, which is the same thing, as more negative. So they're only showing you the positives. So whatever the negative ions are, those will flow as well. And they didn't tell you, so you don't have to worry about it. But they're asking about the positive ion travel. So if this is becoming, this side over here is this half cell, we call it, if this is becoming more positive and this is becoming less positive, where do you think the electrons are, where do you think these ions are going to flow? Well, hopefully you guessed that the aluminum ions are going to flow through the salt bridge to make sure that when this starts to go down in positivity, these positive ions come back and counter the idea or the fact that these are disappearing. So it's going to replenish the positivity here. If we didn't have a salt bridge, this is going to continue to get more negative, and if you build electricity negative charge in here, the electrons not going to flow as much. When they don't flow, the reason is because we already have a bunch of electrons here, and negatives are going to repel the negatives that are trying to get across. So if I keep this positive, it's going to keep the flow of electrons from negative to positive all the way through. Okay? Last thing here is the balanced net reaction. Hopefully one thing that you noticed here is that I've got 3 electrons in the oxidized part of this, the half cell. And in this side, I've got 2. So I've got to do some math to take care of that. So I'm going to rewrite this as quickly as I can. I'm going to put this one under it. But I have to multiply both of them because I've got a 2 here and a 3 here. So I'm going to multiply the top by 2 and the bottom by 3. So I'm going to rewrite this now. I'm going to choose green this time. So this time I've got 2 aluminums, 2 times the ion, and 2 times the number of electrons. 2 times 3 is 6. I've got 3 cobalt plus 2s. 3 times 2 is 6. And 3 times that cobalt is 3 cobalts. Now, some people are not drawing this line. I want you to draw that line. And a fair number of people weren't even finishing this. So you've got to finish it. So what do I do with these electrons? Since I've got 6 electrons on the reactant side and 6 on the product side, I'm going to cross those out. They've canceled each other out. Now I can finish. My overall reaction is 2 aluminum 0 plus 3 cobalt positive 2s yields, look, I didn't multiply that 2 by that aluminum. Check your work there, brother. So that's 2 aluminum 3 pluses plus 3 cobalt zeros. Again, make sure you're putting oxidation numbers above every one of these. Okay? Caught a lot of people just putting Al or CO. All right, is this balanced? 2 aluminums, 2 aluminums. 3 cobalts, 3 cobalts. That's good. How about charge? 2 times 0 is 0. 3 times positive 2 is a positive 6. 2 times positive 3 is a positive 6. 3 times 0 is 0. Positive 6 equals positive 6. There's your answer. And that would go right there if you wanted to. Okay? So I'm going to post two other things. And those are just for review. And then I will, it's not going to be any homework, but I'm going to put Regents Review book questions there. And then I will give you the answers for them. And I will also post your test. Okay? Take care.